Right, so yeah, I'm going to talk a bit about environments and managing environments and some thoughts on how to do that using infrastructure as code, obviously, because that's my thing. I'm currently at work on the 3rd edition of the Infrastructure as Code book. So I've got just some of the ideas here are kind of coming into that and things that I've been thinking about as I've kind of pondered over the past kind of 3-4 years since the 2nd edition. What are things that we need to think about? What are the kind of things to learn about? So this is kind of start with a very high level, view or thought of where as an industry we've kind of been going, right? So we started out in what I like to call the Iron Age of IT, and this is when obviously servers were physical things that you could touch and take in and out of racks and that kind of thing. And in those days, and in that kind of mindset, and this kind of path that I'll take us through is not like a really discrete periods of time, but different organizations are kind of at different stages and so on. But the idea was often that IT is a separate thing from the business, right? And in fact, if you went to a lot of consultancies, they would tell you just hive that off, let somebody else do it, outsource it all. Don't worry about technology. That's not something you need to think about, right? Technology is not core to your business. And then there was a time, let's say 15, starting maybe 15 years or so ago, where cloud started emerging, the ideas of DevOps and infrastructure as code and these kind of things started kind of emerging towards the mainstream, right? And I would call this the age of shadow IT, because this was stuff that was going on inside startups perhaps, or inside maybe some kind of roguish groups within larger organizations. And so the idea was to move fast and break things, right? We need to do this separately. If you're in a large organization, kind of experimenting with cloud and maybe selling online, if you were an offline, say, retailer, the idea was often, well, we need to kind of stay away from our old IT folks because they're just going to get in the way. They don't understand this stuff, and they worry too much about, compliance and stability and stuff like that. We need to kind of we need to move fast, right? And then I think, let's say the past kind of 5+ years, we kind of moved into this kind of, people started realizing we need to take this stuff seriously, right? So those same consultancies that would tell you, oh, outsource all your IT, it's not core to your business, we're now saying you need to do a digital transformation, you need to become a technology company yourself, right? And so this became seen as more and more important, and established companies were worried about the digital upstarts coming in and eating their lunch. And it started with maybe things like retail and media, and then moved into areas which previously people were saying, well, this is never, like finance, right? Healthcare is never going to, move to the cloud and all this kind of risky stuff. Things started becoming more mature and started realizing the benefits that were there for this, right? And so the idea was to scale at all costs. Well, we need to move quickly because otherwise other people are going to come and eat our lunch, right? And so this is where you can kind of measure this by in your organization, how many different teams are building their own Kubernetes clusters, right? That's kind of a measure of how much you're sprawling and everybody's kind of rushing to grab kind of land and make stuff happen. I don't think we're in the final state of, cloud age. I think there's still a lot to learn. We're learning a lot, but one of the things, especially I think with the way the kind of the economy is these days, is that the focus is a lot more on growing sustainably. And I mean, obviously there's sustainably in terms of the environment and society and all those kinds of things. But even as a business, we can't afford to just have, be spraying money around and investing in all kinds of different things and letting everybody do whatever. I think at the same time, though, it's not a case that, we need to kind of stop spending, we need to stop investing in this and just kind of hunker down. I think there is still that need to grow, right? So it's just a matter of growing sustainably. When it comes to infrastructure, obviously infrastructure is something that should enable business value, right? And enable the organization's kind of strategy. But oftentimes it's just there's a big gap, right? And that gap can seem quite far to the point where, I've been to clients where they bring me in obviously to help with the infrastructure side of things, and I'll say, well, great, let's I'll talk to the infrastructure folks and say, let's talk about the kind of applications and workloads that run on top of your infrastructure, and they'll say, we don't need to worry about that, right? We're just building the infrastructure. That's a separate thing, right? And then I'll go over to the product side with folks and say, we need to kind of talk about your infrastructure strategy and the architecture that we need to support what you're doing. And they'll say, that's just like plumbing, right? That's, there's no real connection in a lot of people's heads. Or people will say, well, we've got a strategy for infrastructure, right? We're using cloud, right? We've picked a cloud vendor, signed a partnership deal, and that's our infrastructure architecture and strategy. Now, there's a guy called Corey Quinn. You may have seen he writes a weekly newsletter on AWS where he lists all the kind of announcements. He summarizes all the announcements that came out of AWS, just AWS, in the past week about new services and offerings or changes to services and offerings. And the fact that it needs a newsletter every week is, I think, a telling point. So he put out an article called there's 17 different ways that you can choose to run a container on AWS. And then sometime after that, he wrote another article. There's 17 more ways that he's discovered you can run containers on AWS. Now, that's interesting. Then recently, he's done 17 final ways. And so, there's some of them are kind of a bit of a stretch. They're very kind of niche situations in which you would run containers. But also, I'm wondering whether that's really going to be the final ways to run containers. But the point here is that as a platform, there's a lot there, right? So AWS or any cloud is not really a platform. It's not a complete platform. It doesn't give you, something ready to go, give it to your developers and send them off, because there's a lot of decisions to make and a lot of work to do. Fortunately, we have a whole kind of, there's the Cloud Native Computing Foundation has like a list of tools. They've given us a list of tools and platforms and other things that you can use to help manage all your and create and build a platform on the cloud, right? So that's really nice. Similarly, though, there's a lot for you to do, right? And so what I would say about this is that cloud is the start of an infrastructure strategy. It's not the end of the conversation, right? There's still a lot to do. And so how do we do that? What do we do? And I think the important thing, again, is to think about what is our strategy for our organization, and what do we need to do for our infrastructure in order to support that, right? So there was a article by Sarah Taraporwala, who's our head of our EMPC service line in Australia. She published on Martin Fowler's website. I forgot to put a link in here. But that was quite inspiring. She talks about about having a technology strategy, building a technology strategy that supports organizational strategy. And I found that very useful to help then frame, okay, then how do I take that to the next level when I think about infrastructure strategy? So there's things like, just as some examples of strategies that your organization may have, or things like, growing the business. Maybe you're going to do that by adding products, building new products, or acquiring companies with products, or those kind of things. Maybe you're going to add users for your existing products in some ways. Maybe you're going to deploy to new regions or new markets or what have you. There's also the side of kind of sustaining the business, right? So there's a lot of things that go into there, but there may be things at the organizational level where we're worried about, things like operational quality. Our users, maybe, do they have confidence in the speed of our application or in the stability and those kind of things? So that's something that we need to think about. And so in terms of the infrastructure capabilities then that we need to provide, we have to kind of think about, so, okay, what are the kind of things for what the business is doing that we need to do as infrastructure? And so as an example, if our strategy is to add products and build new products, let's say, we need to think about how do we provide delivery environments to the teams that are building products? How do we make sure to make that, kind of effective? And I'll talk in a moment about ways of kind of like thinking about measuring how well we're doing at those kind of things. It can also be things about providing customer environments or market environments, as I'll talk about later. What I mean by that is, okay, we've decided that we're going to expand into another country, another region of the world, or what have you. How do we do that? How do we provide infrastructure to deploy our software in there and make that available to customers in those locations? And then for sustaining the business, there's things like managing the cost of ownership. Now, obviously, one side of that is things like cloud costs is a big concern because it can be difficult to predict and can be surprising. But then there's also, I think, a big challenge that we have is managing the cost of ownership in terms of the people that we need in order to kind of maintain environments and keep that operational quality up. And things like compliance, and there's loads of other stuff. But those are like some examples of the kinds of capabilities you might decide we need to kind of think about each of these things. And in terms of like measurements, so if we talk about going back to the providing delivery environments, and this is for software development teams to get their work done, right? Well, that one kind of set of metrics is the 4 key metrics from DORA, which these are measuring in terms of software how quickly can we get a feature out into our users' hands? How often are we able to do that? How reliably are we able to do that? And I think for infrastructure, like one of the things we need to keep in mind is that we are an enabler for that, or we can be an impediment to that. So a lot of the times when we look at those metrics, and like let's say we do like a value stream map or whatever, and work out, okay, this is what is taking us, the time that it takes us to get a software release out the door, what's involved, and a lot of time it's down to, infrastructure and environments, potentially taking a while or what have you. For setting up a new product, so if you have, if you're going to add new products fairly frequently, if our strategy is we're going to be kind of aggressive on that, what does it take to get the development environments and test environments and everything set up so that we can do that? What does it take for, if we're doing, adding services or microservices, say, for using existing tech stacks that we already have? A lot of organizations, even though we already support all the tech that we might be wanting to use in a new microservice, it still takes a fair bit of work of getting a bunch of people together and making plans and getting things signed off and all that, and it can take months, right? And much less if we have like new tech that we want to use, if there's new kind of emerging areas. If you think about things like machine learning and AI and all that, there's a lot of new tech out there. How quickly can we make that available and use it in production for new products? And if the strategy is acquisition, or even if you have kind of gone through that phase of lots of different teams building different products and stuff, how can you bring it all together? How can you consolidate the half a dozen different Kubernetes platforms that different teams have built in the organization, right? And so there's things around measuring the time it takes to get like different types of integration, different levels of integration of those things into our system, and again, how does our infrastructure support that and improve those kind of metrics? And just in some of the other kind of things, if we think about those customer environments or market environments of getting out to other countries, or maybe if you're like a SaaS business, you're going to stand up instances for different customers, to provide your product, maybe as a white label, that kind of thing. So how long does that take, right? And again, this is one of those things that organizations, even ones that are doing this as a business or have this as a strategy, may not have thought so much about, or may not think so much about how long is it going to take if the leadership goes out and signs an agreement that we're going to kind of sign up with a partner and provide our service or our products in another country. How long is it going to take us to actually get that up and running? And then what's it going to cost for each of those environments? Like for each of those customers that we sign up, each of those countries, are we going to have to set up a whole new operations infrastructure platform team for each one of those? Is that going to be our model? And the thing is, if you don't think about this stuff and you don't have an approach for it, the answer is you will, right? You'll have a very high, very kind of linear cost of ownership for your growth. And then for the kind of the sustainability stuff, the cost of ownership, there's things about kind of building on that last point. What is the incremental cost for every product that we offer, every customer that we add onto our platform, every developer that we add into our teams? How much is it going to cost to support that in terms of infrastructure? That's kind of a lagging indicator, but there's like some leading indicators, like the variations that you have across your environment. And so I think about technical debt in the terms of things like versions of software. So a lot of organizations will have, if you look at like the versions of software that they're running, like the core software maybe from a vendor or what have you, or things like the Kubernetes or the databases or what have you, operating systems. A lot of them are running stuff that's very old and even out of support, or they're having to pay extra to the vendor in order to continue support for something that the vendor doesn't really want to support anymore, right? And that's like on a high level. And then there's also the micro stuff of like when patches and updates come out, how many different versions of those? And a lot of teams end up where you have just the new environments that we create, a new server, say, will have the latest updates, but like the old stuff stays on the old stuff, right? And so you end up with a lot of different numbers of, different versions of things, of the same things running, which adds to the cost of ownership and adds to the unreliability of like doing updates, right? It adds to the time and effort it might make. So if there's a security patch that needs to be rolled out, how quickly can you roll that out? If you've got a lot of variation in the versions or in the configurations of things, let's say across, you're running in a dozen different countries and all those environments are a bit different, it can take you a long time to get updates rolled out. And in a lot of cases, when you look at the path to production environments, development, test, and so on, a lot of those don't get those updates, right? Because it takes too much time. And in order to update the development environment, we need to stop development for a couple of days. Everybody has to stop work so that we can update it, and then it goes wrong, and so on and so on. So we just don't bother, right? So environment architecture. I'm gonna kind of go through a few what I'll call like anti-patterns and some ideas for patterns of how to kind of architect, design, and implement environments at a very kind of high level. And so from a kind of general point of view, what we're trying to achieve by doing this is we've got multiple product development teams that we need to provide infrastructure to, right? And how do we do that? They may have different applications and so on being built. And so how do we do that? So a very common anti-pattern is monolithic environment. And what this is where you've got the whole environment is kind of defined, provisioned, and managed as a single unit, a single architectural unit. So from an infrastructure code base point of view, you might even be like a single Terraform project. I worked with one client, or some of us in the room as well, worked with a client who had a Terraform code base that when you ran Terraform apply, it would take 2 hours to run. They had one file called rds.tf, which had 60 MySQL database instances in it. And it's not always, and so like the first kind of approach that people were thinking about, well, how do we fix this, is just kind of break it up into some separate projects and all that, but you can still get, even with, if it's it can still be kind of a single kind of massive stuff, and so even if you can run Terraform in a couple of different times or what have you, you still might like have a lot of coupling between things. And so like, how does this happen? I mean, Conway's law plays a part of it. Environments are owned by one team, so they're gonna not worry so much about kind of decoupling of things between it because it's all owned by them. They can change all the different parts if they need to. But also, it's just kind of an organic thing that happens, right? Because you don't start out, with those 60 MySQL database instances. You start out, we're going to have like 1 or 2, and so having a single project makes sense, right? You're not going to break a very simple environment into a bunch of different, different projects. You're going to kind of do it as one, and it just kind of grows over time before you kind of realize what's happening. And so, yeah, the consequences are every change that you make kind of grows the cost of it in terms of the time, in terms of the effort, and the risk of what you might break with that change grows kind of exponentially with the size of the environment, because the more things you add into the environment, the more things can go wrong and the more kind of complicated it is, and the harder it is to fix. Like, you run that Terraform apply, it fails, and you really scratch your head around, okay, what's broken, why did it break, how do I fix it? How do I fix it in a way that's not going to break something else, and so on. And so there's kind of, in terms of those measures that I talked about, the metrics, you're going to have lower effectiveness of making infrastructure changes. So if you take those 4 key metrics, say, and look at those not just for applications, but for making an infrastructure change, rolling out an update or a patch or an improvement, it's going to be hard. It's going to take a long time to roll out an update everywhere. You're not going to be able to do it as often. And so that's going to lead to kind of more technical debt and so on, and also slower time to market or to value for getting like new things out there and so on. And the technical debt, as I mentioned, you're going to have more, because it's hard to change things. Things are going to get changed less often, and it just kind of spirals, right? This stuff. So what I'm suggesting as an alternative is what I'm calling the composable environment design pattern. And the idea here is, we're going to break our infrastructure into separate units that can be deployed separately. And this is like very, they can be independently delivered, so that you can take a separate part of your infrastructure, let's say just like the part that makes a Kubernetes cluster, and you can deploy it on its own. You can run tests against it, and then you might have another bit of infrastructure that's for something like your networking or so on. And you can kind of break those apart and do them really independently, not just as separate things in a big project, but as potentially separately, kind of even separate teams owning these kind of things. And obviously this draws on concepts from the kind of decentralized architecture that you have with like microservices or data mesh and all those kind of things. So it's kind of the same concept but for infrastructure, really. And what I'd recommend is like having an environment base plate. And what I mean by a base plate is it's like really minimal. It's not like a landing zone, which has like your networks and say policies and things like that in there. It's less than that. Like those things should be implemented as infrastructure products and packaged up so that you can deploy, and like you can deploy different ones in different environments depending on what they're used for and how they need to be used. Like the base plate is really just like, what do I need in order to deploy an infrastructure product into it? It might be like a kind of configuration registry and an account and so on, but just like the very basics. And this lets us decouple the delivery of those different parts of the infrastructure. It also helps us to align things to the workloads. And so, yeah, we can also build these around user concerns. And so I'm going to talk about some more kind of anti-patterns and patterns, but this is kind of at the core of the patterns I'm recommending. And so, like, some of the things is kind of like what am I going to talk about in a moment? It's like we can align the infrastructure around user concerns rather than around functional or technical concerns. We can deploy subsets of our infrastructure for specific purposes. We can test each of those infrastructure products. We can really kind of test it on its own and make sure it's really robust, and also measure things like you can measure the cost of each kind of those different kind of packages that you have. What are the implications in terms of, like, say, cloud hosting costs and so on. You can deliver improvements, updates, patches, fixes, and so on to each of those products independently. And yes, there are dependencies between them that you have to manage, but you make a kind of clean boundary so you can really understand clearly what you're changing and what the impact is going to be. And it also helps you to kind of share and integrate different implementations, which means you can take a more kind of collaborative approach across an organization. So rather than having one team build all the infrastructure, you might have different teams building different parts, or even even a product development team that needs some special infrastructure that other teams don't need doesn't have to ask a central team to create it for them. There's like, you can create it, and here's how you do that, right? So in terms of kind of thinking about how we provision infrastructure, how we provision environments, and in relation to applications, the horizontal, so most of the way we do infrastructure these days, even with infrastructure as code and even with cloud, is very horizontal architecture. So we tend to design and build infrastructure as one kind of unit, one blob, and then we deploy the applications afterwards, right? So here's, we kind of have a team lay out the infrastructure, get it ready, and obviously they talk to the application teams, how many databases do you need, so we can add them into our rds.tf file. But it's still like a separate thing. And then the applications get deployed in separately, and then you work out, okay, why didn't that application deploy? We did something wrong in there. This often happens. Again, Conway's law plays a big part in this. That this is how our organization, our responsibility over the infrastructure is. It also comes in as it kind of reinforces, or plays into that mentality. The infrastructure is just like a generic thing. It's not something we really need to kind of think too much about, like what runs on it. Again, I had that team that would just like refuse to talk about what applications run on top of their infrastructure. That is not our problem, which drives me nuts. And so, yeah, you end up with a lack of alignment between the infrastructure and the software that runs on it, and that creates kind of friction. So the whole software delivery effectiveness, if an application team needs to make a change, like, we need to add a database for a new service that we're going to deploy, or we need to make a configuration change, there's often dependencies, right? We have to ask the infrastructure team, the platform team, whatever, can you go and do this for us in all the environments? And then it's often disruptive to delivery because, okay, we're going to make a change. This one team is asked us to make change to the databases. We're going to have to rerun the kind of Terraform in the environment, or we're going to have to upgrade the Kubernetes cluster to support something that team wants to do. Everybody's got to stop work and wait for us to do this upgrade for that, for that one change. And again, so in terms of cost of ownership, in the sense of, if you look at it like an infrastructure team and a platform team, with this typical kind of model, they're spending a lot of their time handling requests from development teams. Can you make this change for us? Can you make this change for our, we need to do this for our application? And that's not really, I think, satisfying. It's not what, infrastructure folks want to be spending their time on necessarily. There's a lot of, and it leads to a lot of those, those situations where we know we need to, we've got running old versions of our stuff. Well, why are we? Well, we're spending all of our time with this other kind of work that's coming in all the time. We don't have time to make those fundamental upgrades and improvements that we need to make. And so again, technical debt, fixes and updates take a long time, and so they just don't happen so much. And so taking that kind of composable environment approach, and building on that, we can do an application-driven approach to provisioning our infrastructure. And so the idea is that you trigger the provisioning of workload-specific infrastructure on demand, along with the deployment of the application. And by workload, I mean there's applications, obviously, but also you can view things like your platform services as a workload. So, the Kubernetes cluster, your monitoring server, and so on. You can view each of those things as, okay, what infrastructure specifically does the monitoring server need? So we'll deploy that. We'll design it and manage the deployment together with that. Right. And so this is where things like GitOps and infrastructure as data can be useful, can be kind of contribute to this can kind of play nicely with this approach, although they're not necessary for that. But just the idea that you have this kind of separation of kind of ownership or of concerns between the active. Okay, I can, as an owner of an application, I can specify this is the infrastructure that I need. I need a database. I need a message queue. I need this and that. And then I can deploy my application, and then the right stuff happens. These infrastructure products get pulled in, and they've been tested and so on. So it's not just saying development team, you've got to go and build all your infrastructure from the bottom up for what you need. But it's like you can use this thing that's available to you, and that's well tested and so on. And so it can just help to reduce those dependencies between infrastructure and platform teams and kind of development teams and so on. And it can align the infrastructure resources with the need. And that helps with a lot of things like, even with like cost attribution, because you can say, okay, now we can know, like, what are we spending, across these infrastructure products, and how can we align, oh, this one is kind of really costing a lot. What are we using that for? We're using it for this application. Does it need it? Are there things that we can look at to optimize? As opposed to it being a part of that big horizontal environment where we're spending a lot on all that stuff, and we're not really sure, it's hard to understand why we're spending all that money. Lower cost of ownership. So, again, the infrastructure teams should ideally be spending less time on the routine stuff, right? They can focus on different things. They can focus on like making those infrastructure products, for example, and making those really good, but not necessarily have to do the kind of routine deployment stuff and all that provisioning. You can, you reduce the bottlenecks, right? So an application team, not only can they potentially deploy their application to all the environments through to production without having to ask somebody else to do things for them, they can even potentially add things. We're going to add a new microservice, give it a database, give it a message queue. We don't have to talk to anybody as long as we're using the kind of existing things that are available to us. And that can make things really, really effective, right? Faster time to value. And higher operational quality, because the infrastructure, again, is very well defined. Okay, where are we doing our monitoring, and how does it work? Well, it's right here, and we can kind of look at that very closely and make sure we built it properly. So I'm going to talk about two different use cases of using multiple environments. What I've talked about right there was just kind of an environment. Of course, the real complexity comes into when we have multiple environments to manage. And the two cases I'll talk about are the delivery environments and the path to production. And then I'll talk about those kind of multiple customer-facing environments. So, again, how do we support the path to production? Well, we have, a set of stages, oftentimes more complex than this, sometimes more simple, but your software release is going through different environments and being tested in them. All right. So one anti-pattern we see a lot is what you could call the crowded environment anti-pattern. And it's not just a matter of it being shared, but this is a matter of environments being shared by multiple teams to do things that don't actually rely on what the other teams are doing. So this is that case where we don't have that many environments. My team, we're going to make a change to our application. We want to test it by itself. You're going to have to use that environment, and then you're going to maybe have to wait on other teams or so on. Why do we do this? Because it's easier to share. When your environment architecture is that kind of monolithic and horizontal thing, it takes a lot to set up a new environment, and so you don't tend to do that very often. You tend to say, we've got these 5 environments, you're going to have to use one of those. And so impact of this is, obviously, again, so, soft delivery effectiveness is kind of a theme to some of this stuff, isn't it? Because you might be blocked waiting for an environment to become available. Or because you see this happen, right? So you deploy the software, it fails, or you get it working and you run tests and the tests fail, and you bang your head for like a day or so, and then you realize, oh, it wasn't something that we did, it was another team has made a change in the environment or deployed something that we depend on, and it broke us, and you don't know, so you waste a lot of time that way. And then there's kind of a paradox here, because so you don't have enough environments, and so you get these kind of constraints because of that, but also you find that you're spending too much money, you actually have underutilized resources, right? There's this kind of paradox, and then I think the reason is because what will happen is, you'll set up an environment. We need to do some performance testing, and we need a new environment for that to do some kind of testing, say performance or otherwise. So you set up that environment, you carry out the testing, and then what happens afterwards? Well, we're not going to give it up because it took us like 6 months to get the infrastructure team to create our environment. So we're going to hang on to that, right? Or it's just that like, you add stuff into the environment to test some things, but maybe you don't use that all the time. But you don't have the flexibility to kind of scale environments down or remove them or so on. And then because of that kind of sharing, again, you get that disruption of, we need to take that environment down that like, a dozen teams are all testing their software in so that we can upgrade Kubernetes. And so, it's going to take a day or two to do that. Everybody needs to stop work. And well, maybe we shouldn't, right? Maybe we'll just do it to the production environment. We'll upgrade the production environment. We won't upgrade Kubernetes in the development and test environments because, we don't want to stop everybody from working. They complain too much. And now you've got these differences. The thing you deployed in and that worked in the dev and test environment doesn't work in production because it's running on a different version of stuff. So as kind of an alternative, again, building on the composable, the idea of being able to compose an environment is having just enough environment, right? And this is the idea that rather than having that, if your full production environment might look like this, it might have all the things in it, but that application team that needs to kind of test just something that they're working on can create an environment and deploy just that and do just the testing. They can use things like fakes and mocks or what have you for anything else they might depend on, but they don't have to have a full-blown environment for that. And so you can do this because you have low barriers, right, to provision infrastructure, to provision even a whole environment, and selecting, and again, depending on how kind of mature your kind of tooling and setup is for this stuff, it might be something that application team, that application A product team can just do on their own and don't even have to ask anybody about. Maybe they have to like put in an expense code or something to make sure the costs are attributed and that there's budget for it and so on, but they don't need to ask somebody, hey, can you go and spend a week or two setting this up for us? And so you get that faster time to value because the people who are working on something and needing to kind of be able to test it out can do that really quickly. And you can reduce costs by provisioning only what you need. And also by removing it when it's not in use, right? Because if the barriers to creating an environment so that you can do something as a kind of a one-off are really, really low, then you don't have that pressure, well, we're going to hang on to it because we might need it later, because if we need it later, we can create it again later, right? And so you can just tear stuff down when you don't need it. And then you can make sure that you're using the most up-to-date infrastructure and so on, because you're just using the individual packages that you need. Right, back to an anti-pattern. So when you have those multiple environments in the path to production, a very common thing is what we can call snowflakes as code, right? And so the idea here is that for each environment, you have a separate copy of your infrastructure code, your Terraform project, your CDK project, or whatever. You've got a whole separate copy of it. And when you make a change, maybe you make it in your test environment and you test stuff, and then you copy the changes over to the next environment, making sure to replace all the strings where it says test with stage so you don't kind of mess it up, and don't accidentally do that in your production and be using your production database and staging or whatever. And the reason why we do this is, there's it's the easy thing to do, right? It's just, it is easier to manage because you need variations between environments. You need them to be different. You don't need, necessarily a development environment to have the same kind of cluster size and those kind of things as you have in production. And so you need those variations, and it's the easy way to do that, at least in kind of to set it up in the first place, is just to copy the code and edit it. And then it's maintaining it is kind of the hidden cost that comes up later, is that's what you kind of add on. And so, yeah, every time you need to make a change, again, those upgrades, patches, configuration tweaks, and so on, you need to change those in each environment. And so you have a higher cost of ownership for each of those environments. And again, I'm repeating myself a little bit here, because it's the same things happen, right? So it's like you make a fix in production because there's some issue, maybe a performance issue, or maybe some kind of an outage or something, and you fix something in the production environment. And you don't necessarily apply those same fixes to all of the other environments, and so you get those kind of differences between the environments, which leads to lower kind of delivery effectiveness. And so your teams are like, it takes a lot of work to deploy your software into each environment, because even though you got it deployed in the last environment, you have to make some tweaks in this environment, and so on. So the kind of composable way to kind of deal with that, or the way to leverage composable approach, is to have those kind of packages of infrastructure code as something that you just reuse across environments, just like you do with software, right? So with your software, if you've got a Java application, you're not copying your Java, project source code into a separate, project for each environment and recompiling it and rebuilding it and editing strings and stuff and tweaking it for that. You're making it configurable across those environments. So yeah, you have those kind of version packages, you put version numbers on them, treat it the same way you would software, a software artifact. Manage the variations between environments using configuration parameters where possible, or in some cases where you're kind of forced to it, you might use a different package, right? So we have maybe the production environment has a networking package that has like really, robust kind of, security on it. It's doing things like, traffic logging and all these kind of things. And so maybe you have a different package that you use for other environments. Obviously, making sure you test that production one somewhere before you use it in production. But in order to do this, like the consequences, it takes work, right? Because you need tooling for this. You need to set this stuff up and integrating it. You need to kind of do that. And again, it's the upfront thing. Most of those anti-patterns I've talked about, the reason that we end up doing those is because it's the path of least resistance to get going, and to kind of to do it in a more kind of composable way takes a lot of work. But it does get you the faster time to value, the technical debt stuff I've talked about. And then the operational quality thing is important because you've tested your infrastructure code without, in a, say, a development test environment, and really you tend to test it even before you put it into a development environment, just the infrastructure side, because, for infrastructure, development and test environments are, they're production, they're business critical. So you test it first. You deploy it into each of those environments. Ideally, you run application tests and so on with the changed infrastructure so that yeah, it's it's good and it's solid all the way through. And so the kind of final bit here is I'll talk about a similar kind of thing where you have those multiple market environments, right? And so what I'm talking about, so in one case it's like you've got different countries to roll out into, right? Or you might be like, so I worked with Andrew was here somewhere. We worked at a company that was doing they're a SaaS provider of a core banking system, right? And so they had multiple customers who used their kind of core banking software that they built and ran for them, right? So the kind of ideal way to approach this is to have this kind of single environment, right? Because it's easier to manage if it's just, we have a shared tenancy. All of our customers, all of the countries can be served off of this one thing. And that will help us to keep the cost of ownership low, right? In practice, you often find yourself forced into the kind of multiple single tenancy environments, right? So a separate one for each country. And the reason why you end up with this, it might be commercial agreement. So in the case of that core banking SaaS software, like your customers may not be comfortable with you hosting, their customer data and transactions and so on in the same system as maybe their competitors, right? So they're like, no, we need to have separate ones. Or there might be regulatory requirements, especially for those regional things where you might have things around where can you maintain private personal data of your customers, right? And so there's a lot of reasons why you end up forced into this. And the worst, I think, what happens is when, because of kind of the awareness of how messy this can get, the decision we made at the beginning, we're not gonna do this, right? We're gonna have that shared tenancy. That's how we're gonna build this system. And then what happens is, you run like that for a while, and then the bosses come in, and it's like, we've just got this somebody online who's gonna they're gonna buy, and they're gonna it's gonna be 50 million euros, right? But they're refusing to do the shared thing, and so you end up having to do it with an architecture that you didn't design to do it, right? And then that gets really messy. So what you see is these kind of snowflake environments, exactly like with the path to production. What you see is you've got a separate copy of the source code for each one of those environments. And again, that's the easiest thing to do, right? Especially when you need to customize it, because often, we've signed an agreement with a partner in this country. They don't want exactly the same features, or they want a new feature or whatever, and so we need to kind of like customize what we're actually running in there for them. And so, okay, we'll just copy the infrastructure code and potentially the application code, and we'll like edit it and tweak it for that, right? And so again, the cost of ownership goes up, the technical debt goes up because you're having to manage all these maintain these separate environments and the code for them. Oh, and then also there's the whole, like, how do you do the delivery for these, right? Because you're going to need to test each of these separately, right? Before we can test our applications to be deployed into these different Snowflake environments for different countries, well, we need a separate staging environment for each of those countries, and maybe we even need all the way back into the kind of development test environments all need their separate kind of paths to production. And so this kind of like, this multiplies really, really fast, even higher cost of ownership and even more technical debt. So what would we like to do instead? We'd like to use that kind of composability thing. So if we have infrastructure products and if our applications, our software systems are designed in such a way that we can say, you know, we can deploy the pieces that we need. So if there's a, you know, if the partner in one country that we're working with wants a subset of the features that are you know, that we have available, we can deploy just enough infrastructure for that in the production environment for there. And by the way, we can kind of test, you know, the infrastructure code and the application code, you know, as a thing. And you will need to do some amount of testing to test the fact that, you know, you have, you know, configurable options, so you need to have some kind of testing for that. You may even need still at least a staging environment, just if nothing else for, you know, customers and partners to sign off on, although it becomes very painful. But, you know, you can manage it much, much better this kind of way. So I'll wrap up here by kind of saying that, just kind of summarizing this idea of having these packaged infrastructure products. One of the benefits is that separation of concerns between developing and using infrastructure. They have kind of a clean separation of concerns of the way you manage that. So you can have somebody, you can have a team that's making an infrastructure product package. So let's say you might have, you know, different product teams might want to run their own Kubernetes clusters. Maybe we're running, like, each team is running like a dozen or more microservices, and maybe the kind of integration doesn't require what they're doing with the other product teams. Maybe there's some kind of, and so you can say, okay, we're going to make a Kubernetes cluster package that other teams can use, right? And so those teams can go ahead and use those, or database instances, or what have you, right? And so that then empowers teams also to build custom. So when I talk about separation of concerns, by the way, I'm not necessarily talking about, that doesn't necessarily have to mean separate teams, right, and silos and all that kind of thing. So you can have, for instance, here's this, you know, maybe this data science team, and they've got some need that other teams don't have for some infrastructure that other teams don't need. So again, rather than saying, you know, we might want to, you know, we have to ask the central platform team to create this for us, and they've got a lot of other stuff to do, and so we might have to wait forever. Instead, you can say, you can build your own infrastructure products for the things that you need within your team, as long as you do it in this way, right? We have defined, here are the interfaces of how you make sure it interfaces with the rest of the stuff. Here are the things that you need to do in order to test it and make sure it's compliant and all those kind of good things. But, you know, there is a way. So you still have the separation of concerns when they kind of deploy their software and so on, but, you know, they're still in the control of that. And the standardization of how infrastructure is packaged can be helpful in a lot of ways, because you can standardize things like your kind of governance and, you know, integration patterns and techniques and tooling and so on, and things like, you know, how they're monitored and stuff, right? So monitoring can work by just, you know, every infrastructure product exposes this thing, and then it kind of gets, you know, pulled into the monitoring system. Or you can look at things like cost, like how much does it cost this infrastructure package, like what are the running costs for this, and that kind of thing. And so you can build infrastructure around the concerns of the users rather than, again, the functional concerns and technical concerns, and aligning, you know, really kind of coming back to what I was saying very early on. This is about thinking about what are those strategic goals of the organization, what capabilities do we need to provide for them, how can we measure those, and then we can kind of, this helps us to kind of build stuff in a way that delivers on that. So thanks.